Hello everyone, welcome to the lecture 6 of the series. So in this lecture, we will learn how to implement multiple linear regression using PyTorch. In lecture 5, we'll learn how to implement simple linear regression with PyTorch. Let's start this lecture. Okay, so the first step is to import all the necessary libraries. So the first I have to import Torch, then I will import NN module, which is present in the Torch as NN. Then I will import sklearn. I will import train test split from sklearn model selection because here I have to split the data into training and testing. Then I will import matrix from sklearn or matrices, and I will also import numpy, pandas, matplotlib. Let's run this cell to import all the necessary libraries. Now, student, before going further, I want to tell you the code and the dataset for this lecture is present in the first comment of the video. Okay, now the next step is to import the data. The data I am going to import for this lecture is known as college_data.csv. So this is the CSV file. In the previous lecture of the series, we learned how to import the CSV file in Google Colab. So the first step is that in order to import this, we need to mount the drive and we need to set the path. How to mount the drive and how to set the path, I have explained it in detail in lecture 5 and lecture 4 of this series. So I strongly recommend you that if you have missed lecture 4 and lecture 5, first see those lectures before coming to this lecture. Okay, so the drive has been mounted, the path has been set, and now I am able to read or import the data. So this is a data known as college_data.csv. Let's see the data. So if we see this data set has 4 columns: research, salaries, infrastructure, and expenditure. Expenditure is our target value, and these research, salaries, and infrastructures, these are our 3 features. So basically in this data set, we have to use these 3 features to predict the expenditure, which is the target value. So the features are research, salaries, and infrastructures. Since we have more than one feature, that's why this regression problem is known as multiple linear regression. Now we see that we have 3 features to predict the target, which is the expenditure. It means that all 3 features will work together in order to predict the target value, which is expenditure. But all of these 3 features are not equally important. One of the feature will be more important, then there will be a second important feature and the last important feature. How to find which feature is more important? So basically when we will complete the linear regression analysis, we will get 3 weights. Okay, the first weight will be associated with the first feature, the second weight will be associated with the second feature, and the third weight will be associated with the third feature. So based on the value of the weight, we will decide that which feature is more important. The higher the value of the weight, the more important will be that feature. So in order to get the most important feature out of these 3 features, we need to complete the regression analysis. But there is another way which is known as data visualization. So data visualization can help us to guess or get some idea about which feature is more important. Let's see how data visualization help us. So if we see research, salary, infrastructure, these are the features, and this expenditure is a target value. So if I plot research against the expenditure, salary against the expenditure, and infrastructure against the expenditure, I will get these 3 plots. So you can see that we have expenditure, research, expenditure, research. So here we can see that the effect of research on expenditure, so this is not very much linearly related. If we see the salary, in the salary we can see the clear correlation between the expenditure and salary. So it seems that the expenditure is highly correlated with the salary as compared to research. If we see the infrastructure, we can see that infrastructure has also good correlation with the expenditure, but it is not as good as the salaries. So research, salaries, and infrastructure, these 3 are our features of a multiple regression, and we have plotted the scatter plot of these features against the expenditure, which is the target value. With this visual inspection, we came to know that salary is the most important feature because it is highly correlated with the expenditure. But it will be confirmed only when we will get all the 3 weights of these features. So let's get the weight of these 3 features. So if I see my data set, first three columns, they are the features, that is the value of X. They will make the X matrix, that is the feature matrix, and this expenditure is Y. Let's extract X and Y from the data set. So here I am extracting the value of X. It means I am extracted all the columns except the last column. The -1 index shows that I am not expecting the last column in my data, and dot values will convert the data frame into the numpy array. If I run this and now I want to see X, I can see that I have three columns in the X, that is research, uh, infrastructure, salaries. So these are the three features. Okay, similarly, extract the value of Y, and now we reshape the value of Y, that is we transform into the form of column. The next step is that to split the data into training and testing. So we have X and Y here. This is the value of X, this is the value of Y. Now we will use train test split function in order to split X and Y into training and testing. So we are setting test size equals to 0.2. This 0.2 is the normalized value. It means we are going to use 20% data as a test and remaining 80% data will be used as the training data. So if I run this cell, I will get four output. That is the training data. The Y train means the training labels. Training labels means the target value, X test and Y test. Now this data has been split with the ratio of 80 and 20. After splitting, if I want to see the shape, so it is 200 by 3. Why it is 200 by 3? Because in total in this data set we have 1000 samples. If you see that we have 1000 rows, and if we take 20% of 1000, it is 200. So the 200 samples are in our test data, and remaining 800 samples will be in the training data. So in this way, if we see, our training data has 800 samples and test data has 200 samples. Now, if we see our data, the data need to be standardized. The reason is, if you see, all the columns are of different ranges. So they need to be standardized so that when we train our regression model, it should not be a biased training. In order to standardize the data, I will import the standard scalar, and then I will use the standard scalar on the training part of the data and the testing part of the data. So if I run this, my data will be standardized. Now, after standardizing the data, the next step is to transform this data into PyTorch tensor, which is very, very important. Because if our data will be in NumPy or any other data form, we cannot train or we cannot use that data to train the model. Because we are going to create the model in PyTorch, therefore, it is very, very important that all the data set should be in PyTorch tensor. So the next step is torch.tensor. We are using the same function as we used in our previous lecture 5. And here I am converting everything, that is the training part of the data, the testing part of the data, the training labels and the testing label, all these four components which I obtain. These are the four components which I obtain by using test and train split, and then they will be used here to standardize. Now, finally, the standardized data will be converted into the PyTorch tensor. Now it's time to create a neural network for multiple regression. Now, if we see here, I am using nn.sequential. I also used nn.sequential in my lecture 5 in order to create a simple neural network for simple regression. Here it is a multiple regression. So if you see here, the input features are three, because I have three input feature in my dataset, that is research, salaries, and infrastructure. And output feature is always one in regression, and here in this case it is expenditure. So if you remember in lecture 5, that is in the previous lecture, when we create a model, we use 1 comma 1 because at that time we had only one input. Now we have three input feature, therefore this 3 shows the input feature, and we have one target value, so output feature is 1. So the model has been created. Now it's time to set the parameter. So I am setting a learning rate equals to 0.01. The loss function is MSE loss function. Optimizer is stochastic gradient descent. So let's set the parameter and now set the training. So I am going to train it for 1001 epochs, and I will run a for loop that will run for 1001 time, and it will calculate the loss values for every run, and that loss value will be append or stored in this losses matrix. And here, this is the important three lines of code for back propagation. I have clearly explained in detail what these three means in my lecture 5. So I strongly recommend you to go through a lecture 5 first before observing this lecture 6. So let me run this. So the training has started. You can see at the start of the training, the loss value is very high. And at the end of the training, the loss value is 0. It means that our model has learned everything from the data. That's why its loss value is reached to be 0. And if we want to plot a loss against the epochs, we can see that it starts from some high value and finally it reach to the 0 as the number of epochs increases. So this show a very good and smooth training of our regression model. Now we need to find the value of the weight and bias of the model. If we see, there are three values of the weights, and the reason is that we have three input feature in order to predict the target value. If we see, the second value is the highest, it means that feature is the most important feature. So if we scroll up and see what this feature is, so we can see that this feature is the salary feature. The second feature is a salary feature. And we already inspect from visualization that it is highly correlated with the expenditure. And now with the value of weight, it is clear that the most important feature of this data set is the salary data set. Now, after training the model and getting the value of weight and bias, it's time to test the model and evaluate the performance of the model. So we have already testing data. We will pass this to the model and get the wipe rate. Then we know that during the back propagation, the gradient is attached with wipe rate. So in order to remove the gradient, we will use detach, and then we will convert this wipe rate and y test into numpy. And the last step of the performance evaluation is to check these three matrices. So if you see, the most important matrices, as we discussed in the previous lecture, is that the value of R square is 1. R square is a normalized value and its maximum possible value is 1. If the model is 100% accurate, in that case, the R square comes out to be 1. So this one value shows that our model has learned all the features of a dataset. And look at this RMSE and mean absolute error. These values are also very small. Now, if we want to evaluate the model further means, if you see here, we have passed all the test data to the model. Now the test data samples are 200. Suppose if we have only one sample of a data set, if we have only one sample of a test data, and let extract one sample, and that is 113 sample out of 200. So what would happen if I do not have 200 sample in my test data, but I only have one sample in my test data? In that case, what will happen? We have to pass this as a test data. We can see that we have only one sample with three features, and we will get the test labels, and we will convert this into PyTorch tensor as well. And finally, we will pass into model to get the output, and then we will convert into PyTorch into NumPy, and final step is to see. So we can see that if we have only one sample, it is shown that we cannot calculate R2. That is the R square error. It is not a number. Now what is here coming out as a warning, that R2 score is not well defined with less than two samples. So if we see here, we were able to find the value of R square because we have 200 samples. But if we have only one sample as a test sample, as in this case, we select 113 sample as a test sample. So in that case, we are able to find the value of root mean square error and mean absolute error, but we are unable to find the value of R square. So in this lecture, we learn how to perform multiple linear regression with PyTorch. We read a dataset known as college dataset, which has three features: research, salaries, infrastructure. And we use these three features to successfully predict the value of expenditure. We see that our model performed very well and its R square value come out to be 1. And we also realize that and we also calculate the weights, and we realize that salary is the most important feature out of these three features. So I hope you understood this concept of a multiple regression and how to apply multiple regression using PyTorch. Thanks for listening, and I will see you in the next lecture.